Now, here to talk about the future of bio, gene, and medical technologies, please welcome Professor Gregory Stahl with a warm round of applause.
Thanks. These have been really good sessions this morning, and now we're going to talk a little bit about an aspect of the future that if we ignore it, I think we miss a huge aspect of what is going on. Because essentially, we're at a transitional moment that isn't just in our own history, but in the history of life. And what is happening is that there are two revolutions that are underway. The first of these we're very familiar with, the Silicon Revolution, and Steve Wozniak spoke about that very eloquently. Computer chips, the internet, all these things that are changing our lives in very, very dramatic ways. What is happening, if you sort of step back and look at what that process is that we're taking the sand at our feet, the silicon dioxide, and we're breathing a level of complexity into it that rivals life itself. And that is a huge, huge step. What we're doing essentially is we're animating the inanimate world around us. And nothing is ever going to be the same as a result of that. And a child of that first revolution is the second revolution, which is the genomics revolution. And I speak of that very broadly in that it's essentially about coming to understand our basic biology and beginning to manipulate that, to change that, to control it. Essentially what we're doing is we're taking control of our own evolutionary future. And what has happened is that science and technology have kind of slammed the evolutionary process into fast forward. And it's not clear where this is going to take us, but it is going to be dramatically different from where it is today. As I said before, the world is never again going to be the same as it has been. And this is the underlying context for the changes that are occurring today in healthcare, in medicine, in the pharmaceutical industry, in biotech. And to understand just how big a shift this really is, I want you to consider the previous such shift of this magnitude. It happened 500 million years ago. And it happened when simple biology in the form of cells and tissue learned how to organize simple non-biology, calcium carbonate, calcium phosphate, to produce structures that could be incorporated into their own cells. And so essentially you use calcium carbonate to create shells to make all the sort of protected life available that was much, much larger, and took calcium phosphate, which was excreted, and controlled that excretion process to create bones so that we had skeletons. Essentially, we could build the large potty plants that now are responsible for all of the macro life that is on the planet. So what is happening now is that not simple biology, but complicated biology, epitomized by our human brains, is taking complicated non-biology, all of the computer chips and stuff, and integrating them into a planetary superorganism. And evidence of this is you look at this image of the night, at night of our planet, and look at what human activity has done. And so this union, it's not clear where it's going to carry us 100 years from now, 1,000 years from now. I mean, we think of times that are far too short. 1 million years, 10 million years, even these are short times on an evolutionary scale. It is absolutely mind-boggling. And the big question of our era is one that was alluded to by Steve Wozniak, which is it going to be biology still as we move into the future, or is it going to be silicon? Is silicon going to transcend carbon and nitrogen? And, you know, it's hard to say which is going to be the case. But it is clear that whichever ultimately happens, it is going to be changes in our biology. It's going to be biological insights and such that are going to be important to us. And it is also clear that the heated debates of today about stem cell technology, about germline and genetic engineering, about clones. They're going to seem very, very quaint to future humans looking back on this area. So when you talk about biological insights, the reason that they're important to us is because we're tissue, we're flesh and blood. That's who we are. And so when you think of biological insights, that's what's important to us, to our children, to their children. And it's this impact of technology on biology and healthcare and pharmaceuticals and such that is what I'm going to focus on today. To me, it's very amazing that within our lifetime, we may begin to substantively modify human biology. And this development is already very, very actively underway, and it's going to challenge our sense of what it is to be human, of meaning, of purpose, all of those sorts of things. And the idea that we could somehow transform ourselves into something other than we are today and do that in some short period of time, frankly, sounds a little crazy. It sounds absurd. But actually, only until you take a look at what we did to the gray wolf. So in a matter of tens of thousands of years, actually most of that occurring in the last few hundred years, we've taken the gray wolf and we've transformed it into all this, merely with very crude tools of selective breeding. And now we have much, much more powerful tools. And it is not surprising that lines are already beginning to blur between therapy and enhancement, between the natural and the artificial. So this is the deeper context of the pharmaceutical sort of and biotech arenas and what is happening today. And the reason that it's so important is you take a look at something like human cloning. So cloning doesn't exist. It probably won't exist for several decades. And yet it inspired enormous enthusiasm among many circles. All the possibilities, how we would alter our reproduction in various ways. But much more than that, it generated a lot of angst. Are we going to grow children? Are we going to create colonies of slaves? All of these sort of crazy things that people were thinking about for what is really just a delayed identical twin. And the consequences of that were that it really changed the landscape for a therapeutic technology, which is stem cell research. It really put a stop to that in the United States and Europe to a large extent and created enormous opportunities here in Korea, in Singapore, elsewhere in Asia. So before we delve into the kind of the near-term medical healthcare business implications of sort of the possibilities of the biotech revolution, I want to sketch the larger biological possibilities because they are really at the heart of a lot of policies that are driving attitudes and developments in the healthcare arena. We have to realize that genetics and biology are at our core. And as we learn to understand and to adjust these things, we're learning to modify ourselves. And it's not a question of if we will do that, it's when and where and how this is going to occur. And if you doubt this, then just consider what we've done to the world around us. And in a relatively short period of time, we have transformed our environments. If you walk in any major city in the world, here's a picture of downtown Seoul, you're in these valleys where there are the towers of stainless steel, of concrete, of glass, and it's everywhere. Here's Hong Kong. Here's New York. And now we're starting to take these technologies, and as they become more precise and more nuanced and more focused, and we're turning them back upon ourselves. And ultimately, it's going to change us as much as we've changed the world around us. And it's going to alter the way we have children. It's going to, of course, revolutionize medicine and healthcare. It's going to change the way we manage our emotional states. It's probably going to change the human lifespan. It's going to alter huge swaths of our economy. It's going to create gigantic disruptions in the current ways that we operate medicine and healthcare, pharmaceutical and biotech industries. And that means that it's going to create large opportunities. And I think that those opportunities are going to be very dramatic, particularly I think Korea is very well situated, and I will talk about the kinds of things that it might do if it sees clearly and acts wisely and with and is very brave in what it does. The next frontier is not space as we thought maybe 20 or 30 years ago. It's us. And it's a lot more interesting to us than space is, actually. There are three realms of change. There's our basic biology, there are our minds, and there's reproduction. And you look at reshaping our biology, well, what do we mean? A lot of people think, oh, are we going to add gills? Are we going to have some wings or something of that sort? That's sort of insubstantial science fiction. That's not going to occur. But what about something important, something that we actually care about, like our lifespans? What if we unravel the fundamental process of aging and are able to extend the human lifespan? And by that, I mean not by extra years of decrepitude, but we actually extend the human health span. It would change virtually everything, and it is quite plausible. There are leading gerontologists who believe that the first person to live to be 150 years old is probably already alive today. So that's one area. The second area is managing our emotions. And when you look at Prozac for depression or Viagra for sexual performance, these are just the earliest baby steps. What happens when we understand the mind sufficiently and understand our biochemistry well enough that we can make more nuanced interventions where we don't have the same number of side effects? What if you had a pill that would create the feeling of contentment or fulfillment? You were just happy being you, doing what you do. Could you resist that? I don't think you could. And if you didn't, who would you be? So it opens up a whole new realm of possibilities of interventions which are essentially where we short-circuit human behavioral pathways, mental processes that have evolved in order to encourage behavior that was very desirable for our reproductive success. And a good example of this, a very low-tech example, but shows the kinds of problems that we will have, is sugar. It's great. It tastes very sweet. It's good. It's an ideal thing for us to go and take a little extra energy to go and get some ripe fruit if we live on the savannah. It's not a very good thing if we're living in a pastry shop. And so we spend an enormous amount of energy trying to resist our impulses in this area because it comes too easily. And in fact, obesity is a greater problem today than hunger is. Now, the next area is changing human reproduction. When we can understand what the constellations of genes have to say about who we are, about our risks, about our potentials, about our temperaments, about our personalities, we are absolutely going to want to make choices about our children. And I think we will come to believe, especially with small families, that children are probably a little bit too important to leave to a random meeting of sperm and egg. And that is enormously controversial, that idea, because it's so central to our idea of who we are, of our lives. So these are the kinds of dramatic interventions that are not very far off. And they provide a context for a lot of the near-term developments that are occurring in healthcare and the pharmaceutical industry. They inspire a lot of passionate debate about these sorts of things. And there is absolutely going to be no consensus about our answers. They depend too much on history, on philosophy, on religion, on politics. And there's going to be very vocal debate about these sort of things, all sorts of assertions about what's going to happen. And I spent time on these because there's going to be this background of noise that occurs. And in fact, they're at the heart of our response to what's happening to our own biology and the international differences in the way that we handle these sorts of things, which are going to create significant opportunities that are quite different for different regions of the world. So now I want to turn to the immediate shifts that are ahead for healthcare, medicine, the pharmaceutical industry, and biotech industries. The human genome was sequenced in 2001. It was not an end. It was a beginning. And it's already given rise to some things like synthetic life, which was just announced a short while ago by Craig Venter. And basically that too is a beginning. It seems like a very small thing, but it's going to grow to have a real enormity as we can really create life that have no parents, essentially. And so what's happening is that we are just feeling this huge tidal wave of information that is beginning to wash over us. And it's happened very recently. We're getting an increase in data about ourselves that is about 10 times greater every 2 years. And this is continuing. It's picked up speed since the Human Genome Project. Now, we haven't figured out how to use all this data, which is not just genomics. It's about the proteome. It's about the metabolome, all sorts of aspects of our biology. It's about imagery, about our medical status. It's about healthcare records, all of these sorts of things. So these are many windows into who we are, and we're beginning to draw back the curtains of those windows. And if you look at, we talked about or it was mentioned, the idea of how rapidly computers are evolving. Well, the upper line there is the rate of increase in computer power. The lower line is what's happening with genomic sequencing, the cost it is to sequence a million DNA base pairs. It's much, much faster. It's gone about 6,000 or 7,000-fold in the last 5 years. And this is happening for all these different vehicles of getting information about ourselves. So what this is going to do initially is it's going to greatly accelerate the trend towards personalized medicine, and initially that'll be stratified medicine, where it's small subpopulations rather than large sort of blockbusters that we'll be doing for drugs. And this is not just about tailoring dosage or tailoring drugs to the individual for diseases. It's also things like envirogenomics, where our exposures to environmental toxins. If you're exposed to mercury, there's a very different susceptibility that you have depending on your genetics. If you're a smoker, some smokers, depending on their genetics and their tests that are being developed today, I'm involved with companies that are doing that, it's 10-fold greater than other smokers. So this has a lot to say about our risks in life. So this is going to dramatically change medicine and healthcare. Who is going to get all this information? How will we understand this information? How will we share it? How are we going to learn from it? Who is going to make decisions about what to do? Who's going to pay for it? The very nature of the medical profession is going to have to shift as we try to find new mechanisms and devise new ways of getting access to this information and using this information, both for us as individuals and for the larger national healthcare systems that are very important and which the costs are really positioned to be overwhelming to our societies. And in addition, it's going to change the whole pharmaceutical and biotech industries. And how are they going to change to this era of personalized and stratified medicine, where there aren't big blockbusters, and yet the costs of developing new drugs are huge? And the reason that they're so big is because government, particularly the FDA and other such agencies, have hyper-focused on process and on safety. And they are undercutting innovation, I believe, in translating the basic science into useful medicines because they're too slow, they create a process that's too expensive, and it's too risk-averse. And to give an example of the specifics about that, here in the pink there is the cost of research and development. It's increasing dramatically and has since the late 80s. And yet, the vertical bars there are the number of new drugs. And the dark blue ones are the number of innovative new drugs, new medical entities. They've actually gone down since the late 90s. So that's a very difficult process, a very difficult situation. If you look at the length of time that drugs spend in the clinic, it's gone up threefold since the 60s, and that is associated with the whole regulatory environment and is part of what's driving up costs. So what's happened is that pharmaceutical companies are beginning to shut down their R&D, or at least reduce their R&D significantly, and they're deriving more and more of their revenue. Here's over 2/3 of revenue from top 15 companies that are coming from externally derived products. They're coming from biotech, from the biotech industry. Why is that? Because the biotech industry is much, much more efficient. Here's the cost of developing a new medical entity, a sort of a creative new drug, and it's about a fifth in biotech what it is in the pharmaceutical arena, maybe $1 billion as compared to $5 billion. There are challenges that biotech is facing, of course, and I'll talk about that in a moment. These things are having a significant impact on the industry. And then, of course, we're going to have very broad impacts on society, which I don't really want to talk about right now. I don't have time. But how we select sports people in sports teams. Life insurance, what we do with all this risk information, and how it affects that industry. Nutrition, how we affect information that tells us about the kinds of nutrition that we should be getting individually, not as people in general. And then food itself, as we create modified organisms, genetically modified organisms, and change the nature of food itself. So our accelerating understandings about biology are making healthcare more predictive, more personalized, more preventive, more participatory. And it's really easy to see this. We're interested in prediction. That's why we're devoting so much energy to this. We want to see what's going to happen to us, what's going to happen with a disease, what the future holds for us. But, you know, those general predictions are not really so good in comparison to if we have personalized information about who we are genetically, biochemically, about what we eat, what we've been exposed to, what our behavior is. When we take all that personalized information and combine it with general information about our biology, we get to the point where we can make predictions that are accurate enough that it can lead to prevention. And that's what we really want. And actually, as individuals, we're much more responsive. If you say, look, you are at a very high risk of getting lung cancer if you smoke, as opposed to anybody else who smokes, maybe you'll listen to that. Maybe you won't try and tell yourself that you're not at risk. And then ultimately it leads to participation. So these are the underlying things. And participation comes from a change in this relationship with physicians where it's not sort of the shaman, the physician from on high who's going to tell us what we need to do and be very paternalistic. And no, we're forced to participate and want to participate in the process because we have to provide information, and it's not just from testing, it's from our histories about what we're doing. We have to participate in the decisions so that the ideas of how we'll change our lives or what sort of treatment regimes that we undertake are going to be in alignment with our values and the needs of us and our families. And then we have to be able to follow through on these things. It takes a certain amount of energy and activity for ourselves. So what this means is that there will be a complete change in the relationship between the patient and the physician. And as this occurs, the things that are driving this, I guess, are really these data streams that I was talking about. Look at diagnostics and what's going to happen. Here's an example, one example that gives the idea. An implantable pressure sensor that constantly reads out arterial pressure, which gives a lot of information for a person with heart disease. But how do you interpret all this information? It requires an interaction with experts. It requires an interpretation of these sort of systems, which probably involves expert systems as well as specialists in the medical profession. So these are the kinds of things that are going to be more and more important for physicians that are dealing with us in the future. In addition, we're beginning to pull together, or patient communities are beginning to form. This is a group called Patients Just Like Me, which this is an example, but they deal with every disease, where there are 10 or 20,000 Parkinson's patients that are talking online all the time about the drugs that they're taking, the side effects that they have, the difficulties that they're having personally, interactions with their family. Essentially, they're learning and understanding the disease of Parkinson's at a deeper level than virtually any physicians will, and what it means for them personally. So it begins to change their power or their positioning in the relationship with physicians. And again, that changes the relationship between patients and physicians. And that's something that's very important because the physician can provide a medical context for understanding all this information, but somebody who is really motivated, as we are when we have a disease, and has access to a great deal of information and is impassioned by trying to find out about these things, has to be an active participant. And so where this is taking us is to a whole new healthcare paradigm. And it's challenging as to where that's going to be. It's a maze in terms of how we're going to get there. But we have to have a system that can really tell us what science has to tell us about our health, about the options that we have, the choices that we have that are both about behavior and about treatment, about the consequences of the various paths that we can move down, and also give us assistance in some way or another with implementing those various strategies. So this is kind of the future that we're heading for. And the thing that is without doubt is that significant change is coming. And there are going to be huge pressures to bring down costs. Costs are going to be driving this because we simply, for the kind of quality of care that we need to give, it's too expensive for us to give this today. And we have to have a new arrangements where we're meeting, physicians, experts, where we have access to a lot of this information, and it's going to have to imply web-based and information technology-based tools that give us access to this information. And it's going to bring tremendous challenges for the whole healthcare industry, and that means some very big opportunities because it's really open for grabs in terms of how we're going to move forward. Now, the development of this new system, which is going to come very, very rapidly, the more insights, the more tests that emerge that have import for us, and there are a lot that are looking like they're going to emerge, the more pressure it's going to be because we really do want this information. It is going to be the IT challenge of the next 20 years, of the next generations. This is what our focus is really going to be. And the idea is that this system, whoever can really develop a system that generates value for the consumer, is going to have an enormous positioning in this because we really want this information. It's something that is very, very useful to us. And they will establish a relationship with the individual, which is going to be a very powerful relationship because however you integrate with that sort of a system, and it establishes a comfort level, a trust, the switching costs are very, very significant. So first mover advantage is going to be very important. And what we're talking about is a strategic positioning for what is 16% of GDP in the United States. It's not going to go down. It's going to be 20% of GDP or more. It's going to be at that level throughout the world because what do we really care about more than our health? And right now there aren't very many things that can be done, but increasingly there are going to be things that can be done. So that's very, very important in terms of moving forward. The question is, who's going to be the Google of the whole healthcare arena? And so what does this mean for the pharmaceutical industry and for the biotech industry? What opportunities does it create for Korea? Well, if you look at pharma, there's a lot of lamentation about all of the challenges that pharma is facing. R&D costs are up, as I mentioned before. Actually, the product pipelines are pretty anemic in terms of late-stage pipelines because of a lot of regulatory obstacles, because there are obstacles for reimbursement. There's generic competition that is very, very significant. Sounds like it's kind of grim as it would be portrayed. Pharmaceutical industry is responding by, as I said, cutting back on R&D, by doing mergers and acquisitions to cut costs, and trying to purchase late-stage properties to keep their revenue up. But it's really not that bad. They have lots of revenue, they have lots of cash, and the situation is that there's enormous appetite for healthcare in general, and the pharmaceutical industry happens to be the most efficient part of the whole healthcare arena. It counts for less than 10% of costs and can really cut back on a lot of healthcare costs that are very, very important. So consumption is going to be very, very high as we move forward and only increase. And then the population is aging very dramatically. So there are going to be a lot of old people around. And I've highlighted, this is a figure of the number of people, the ratio between the number of people who are over 65 and ostensibly not working and those that are in the working age population. Right now in Korea, which is the dotted line on the left, it's about 8-to-1 for workers supporting people that are older. In 40 years, it's going to be 2-to-3, or 3-to-2. And all of the populations, particularly in Asia, which are the rose-colored ones, are aging very, very rapidly. So we're going to have to become very, very efficient in our production of all sorts of things, but we're going to particularly have to become very efficient in healthcare, because that's going to consume a lot of our resources. And in addition, if we can develop a system which really fosters the creation of a lot of the innovative medicines that are really likely to emerge, then maybe we'll have people that are a little bit more spry as they get older. These people are starting their second century, and I think it's an anachronism to think that people at the age of 65 are going to be retiring and disappearing from the labor force. Now, the biotech industry is going to be the engine of development for pharmaceuticals as we move into the future. They're in sort of a cash crunch. Public markets are closed, essentially, very, very reduced. Venture investment is down. There are a limited bandwidth in terms of the mergers and acquisitions that are occurring with the pharmaceutical arena. And so there's a winnowing in that area, and that has created the opportunity of a generation for obtaining early stage assets, which the time horizon for the pharmaceutical industry has not been very long. So there are lots of things that are out there that can be purchased. And if you look at the venture arena, which has had a real bravado in the past, it's kind of broken because they're trying to insert themselves between the pharmaceutical industry and between sort of academic and research environments, between biotech essentially and the pharmaceutical arena, and there's not really a reason for that positioning. They would be forced to go out and actually develop things that work rather than to be able to take exits through IPOs and such. So that's a very challenged arena, and it creates an opportunity for companies and for resources such as might be available in Asia. So this is creating a lot of turbulence in this whole arena, which is going to be the dominant industry, the dominant arena as we move forward. And it is creating an incredible opportunity because there is a huge need for new therapeutics. There are areas like Alzheimer's disease where there is absolutely nothing. There's nothing that is useful in that arena. The fundamental science is making enormous strides. There's a lot of very early stage technology, and yet there are these impediments that are structural and regulatory. And we need to get to human proof of principle very quickly with these things. And so what I want to talk about is how to seize these opportunities. And for Korea, I think the answer is a very simple one. It needs not to imitate the West. It needs not to follow. It needs to lead. And that is true for Asia as a whole. And the kinds of things that need to be done, in my view, are very straightforward. It can purchase innovation. This is an opportunity to go out and purchase a lot of assets that are early stage and that would bring very, very exciting technology where you would get global rights to those sorts of things and could do it inexpensively. And that is the situation in the European Union and in the United States. Those things are available. I don't think they will be here for very long because there's a changing going on in the industry. The second thing is that technology can be imported by forging strategic alliances which actually bring innovation and transfer technology into Korea through partnerships that would really essentially get instructions and make Korea, and it can happen with Singapore, it can happen in China, into a world-class area for the development of pharmaceuticals. Now, that requires some changes. And I was thinking a lot about the obstacles that exist with the FDA, with the European Medical Association, Regulatory Association, and it's not an environment that is that fosters the development of new technology in an inexpensive way. And it seems to me that what needs to be done is that an institution like the Korean FDA could set out to ease the burdens of early stage drug development, essentially to make Korea, or I speak in terms of Korea, but it could happen in a few other countries as well, the destination of choice for pharmaceutical development. And it would be not very difficult to do those sorts of things. In fact, the things that need to be done are well known in the West. It just happens that it's very difficult. These are very sclerotic sort of architectures. And if that were done, it could really place Korea in a very, very strong strategic position. And then it could move out to monetize these assets through alliances and marketing partnerships with pharmaceutical companies that give it access to markets in the rest of the world. So that would completely turn upside down the whole sense of getting regional rights and sort of taking a part of that, as opposed to actually going for global rights of this industry that is going to be at the center of our future. And then finally, there's a fifth thing, which is the whole information technology aspect of healthcare. And that healthcare delivery system is going to be very, very important to the future. I said it's kind of a gatekeeper role that will be played. And there are first mover possibilities there. And I think that if Korea were to set itself the goal of having the most personalized, the most predictive, the most preventive, and the most participatory healthcare system in the world, it could give itself an enormous strategic position in medicine as a whole. And the reason for that is that Korea has some very unique aspects. It has a very high-speed fiber network. It has high bandwidth, the best in the world. It has an educated population. It has a good healthcare system. And it also has some aging demographics, which are very, very important. So this would be a project that would do very well for Korea and would also position it with something that was essentially exportable to the rest of the world and would position itself in this sort of future of healthcare delivery, which will be so important. So to summarize, we've begun this voyage that is a journey into our own biology, essentially. And the exuberant hopes of the Human Genome Project, well, they haven't come to pass. There are no designer children. There are no clones. There's been no life extension. There's been no flood of wonder drugs. We're still getting older. We still die of heart disease and cancer. Was it all hype? I think not. I think what the situation is that we have been a little too impatient, a little too eager perhaps, but it takes time to decipher the workings of life and then to turn that information into very useful value. Even processes that are exponential are not instantaneous. And so future humans are going to look back at this era and they're going to look at it as this challenging, turbulent moment. They're going to look at it as this extraordinary time, though, that set the very foundation of their lives. And a cornerstone of that is going to be elucidating and reworking our biology and the biological world around us. And on the way, it's going to absolutely remake medicine and healthcare, and that is going to happen in the next generation. So, to repeat, the next frontier is an inward journey. It's into ourselves, and it is going to be an extraordinary journey. And it is really hard to say who is going to be at the forefront of that journey. Is it going to be the United States? Is it going to be Europe? Is it going to be Asia? I can guarantee one thing, and that is that the key is going to be attitude, it's going to be temperament, it's going to be focus. The field is wide open, and leadership is not going to come from regions that are constrained by regulation, by fear, by caution. It is going to come from the nimble and from the bold. And it's going to move very, very quickly. It's going to come from those who embrace the possibilities of the future and all that it holds for us, and that go for it. And so, make no mistake, we are in the midst of a fundamental shift in the history of life. This is what is happening today, and it's a privilege to be here to witness this change, in my view. And progress in the life sciences is going to be at the heart of this change. It's going to be at the heart of the human future. And our national choices in this realm, right now, in the next decade, are going to have a great deal of impact. They're going to be a key determinant on our national destinies, I believe. And I think that I will close with a quote from Thucydides, the Athenian philosopher, that said 2,500 years ago, something that could have been a speech directly to policymakers in Korea, in Asia, in the United States, in Europe, to all of us, when they wrote, "The bravest are those with the clearest vision of what is before them, glory and danger alike, and yet notwithstanding, they go out to meet it." And that is our challenge. Thank you very much.
Thank you for your thought-provoking presentation. He touched upon the today's revolution and the life science, and it's such enormous consequences at the same time. Thank you.